You're all well, and this will be one of our last couple of online lessons before we return next week, which is very exciting. Today's lesson is very different. Today's lesson is not as much tutorial based and worksheet based. There is no learning task that you need to submit. Today, there's no official Microsoft Word document that you need to submit. Today's task is basically on an honesty policy that we would like you to complete this. And the reason being is because this is not something that is going to be examined on your SAC when you return to school. Officially, because of the COVID situation, the mid-year exams that were going to take up about a week and a half worth of your learning in term 2 have decidedly been cancelled. What that means is that Mr. Sharp and I have been left with an additional week and a half to provide you with some extra learning. So we met and we had a good discussion and we talked about what's one of the first things you heard about Sport and Rec. And I remember that the first thing was I was down in the E-Centre in the auditorium and I explained to all of you that if you select Sport and Recreation, it's going to give you an insight, an eye-opener into Year 12 PE, Year 11 PE, Year 12 Health, Year 11 Health. A really good split between the two. We've been doing things like drugs, enhancing performance, legal and illegal aids. Previously, in Term 1, we were looking at designing good communities that would help promote healthy living. There's been a really good blend between health and physical education. But when I look at the curriculum for Year 12 physical education, there is a science side of things that we haven't necessarily discussed. But during the last couple of weeks of the recovery topics, which are on your SAC, we really started to allude to these science side of things. So I had a discussion with Mr. Sharp and decided that during today's lesson, I'd love for you to experience, listen, and take some notes very basically about the introduction to energy systems. Because if you have a base knowledge of energy systems, it's my true understanding that you genuinely understand how sport, exercise, and physical activity can occur with human movement, how we move our body. So today's lesson is going to ask you to do things, experience them, come back and listen to what happened, watch a clip of something, and then even write down some notes. And those notes can probably even be kept in a different book or at the back of your Sport and Rec book, because those notes are going to be something that if you go back to when you're in Year 11 and Year 12 PE, you're going to be able to have a base level of knowledge and understanding of some of the things that other students have never been introduced to, and that gives you an advantage. So the first thing I'd like you to do, if you're like me and you're wearing a long sleeve jumper or something today, I'd like you to get comfortable, hopefully the heater's on inside, and go into a t-shirt or a singlet. And I want you to find something around your house that is heavy enough that when you lift it, you know that your muscles are straining. I don't want it to be too heavy that you're going to tear a muscle, but just something that's slightly heavy, that when you lift it, you know that your muscle is working hard. And what I would like you to do is complete just 1 or 2 bicep curls. That means that you are going to take the elbow and you are going to bend the elbow while you lift this item. And what I would like you to do is, because you're going to have a t-shirt on or a singlet, is actually look at the bicep itself, and I want you to take note of how does it change shape. Does it lengthen? Does it shorten? Does it narrow? Does it widen? Does it become tense because you can use your other arm to palpate it, which means push and feel around? And I really want you to just really stop and think about when you make a muscle contraction, what does that muscle feel like and look like? Pause this video, go and find something in the house, complete that task, and once you've completed it, unpause the video. That one movement. And hopefully you've been able to get a really good understanding of what the muscle looks like and what it's doing. I want to actually explain to you that if we were able to move open the skin, peel apart a little bit of that muscle and look deep inside that muscle with a microscope, this is how small we're talking, what would actually be happening inside that muscle in order for it to make its movement. And when it moves, it pulls one bone closer to another bone, which allows you to lift the object. And then we'll talk about what this means in terms of sport momentarily. So, if I was able to zoom right in, what I would notice is that inside the muscle, there is actually a compound inside that muscle that is known as adenosine and that tri refers to 3-phosphate. Now, the words are confusing because we might not have heard adenosine or phosphate before, but all they are is different molecules inside the body, different parts of matter that the body can organically create itself through the foods that we eat and the processes that we don't know a lot about inside the body. It's like how we eat food, and the nutrients from inside that food are absorbed and used by the body to keep us alive and healthy. Well, one of the things that the body creates is adenosine triphosphate. And the adenosine triphosphate is actually molecularly looking like 1 part adenosine and 3 parts phosphate. Now, every single time your muscle moves, your body needs to have adenosine triphosphate, and it needs a lot of it. So in order to just complete that 1 bicep curl repetition or 2 that you completed, the body will use up hundreds of adenosine triphosphates. And the way that it moves it up is it actually removes 1 of the phosphates off of the other 2 and allows energy to be released that moves a muscle. So you can imagine that if inside your body you have lots and lots of ATPs and you need to move your muscle harder or faster or over and over and over again, then what would be happening is this ATP gets used, and then this ATP gets used, and all of the ATPs that are sitting inside that muscle when you lifted that chair are all being broken down and used. What we need to understand is that if we start talking about energy systems, we are talking about the body's continuous ability to put that back together. Because ATP, that thing right there, that molecule inside your muscles, is the only thing that allows a muscle to move. And so if we are able to find a way inside the human body to put that back together so that it can be used again, then we've sustained energy that allows us to move our muscles forever. Which means that when we wake up in the morning and we roll out of bed and we stand up, you've already used your calf, your hamstring, your quadricep, your glutes, your abdominals in order to bend at the hips, to move your knee, to rotate out of the bed. Each of those muscles is using ATP the same way as you used it to lift the chair before. When that muscle goes from long to short or short to long, or it widens or narrows, every single time that muscle changes its shape, it's using ATP. And so we need to understand we don't have an infinite store of this. We actually need to keep putting it back together. And that is where the idea of the 3 energy systems comes from. I'd like you now to take a break. Write a set of notes in your workbook or somewhere that just explains one very simple concept. If you want to move a muscle, then you need to use ATP. ATP is the only thing that moves a muscle, and the way that it does it is it allows that 3rd and final phosphate to remove itself, and it releases energy. If you need to pause and rewind to re-listen to any section of that video, please do so. And when you're ready, press play again and we'll move on. I'm hoping that I'm trying to take this nice and slow and steady, and I'm also trying to just introduce you to the language and the concepts rather than confuse you too much with this. I'm hoping that some of you are starting to get intrigued by this and interested because this is what Year 12 PE is all about. And the Year 11 PE is about introducing you to a really deep level of muscles and bones and concepts of how all this works before we move into it. So what we need to look at now is a little bit about this ATP, where we've got that adenosine and those three phosphates with the lines holding them together being full of energy. So when that third one releases, that energy allows a muscle to move. I want to look at this. I want to look at an elite runner exploding off the box. Once you see them explode out of the blocks, look at the calf. The calf is working, both legs. The hamstring is working, both legs. The gluteus working, both legs. The quadricep is working to bend at the hip. The abdominals are tense to try and remain in that beautiful form. Look at the shoulders when it turns its camera. Look at Usain Bolt's biceps, triceps, even into the wrist movements, his chest muscles, his diaphragm that allows his lungs to breathe. All of these muscles that I've just listed are all continuously making movements. And so you can imagine ATP, ATP, ATP having to work over and over and over again to allow each and every one of these muscles to move. Now the problem is that we don't have a never-ending supply of ATP. And ATP is the only thing that moves a muscle. So as I said prior to you pausing last time, we need for the body to be able to put ATP back together. And the body actually has 3 energy systems. Each of those energy systems works in different ways. And it's all based around 2 things. Number 1, oxygen. If the body has a good supply of oxygen, then it can use one of its energy systems. And that one energy system gives you a good amount of energy. And it also doesn't fatigue you very quickly. If we don't have enough oxygen inside the body, then the body has to use either of the other 2 systems. And those 2 systems don't give you a huge amount of energy to put ATP back together and reuse it. But they do happen very quickly. So it's a bit of a payoff. Do I have to wait for a good amount of oxygen to use this system that doesn't fatigue me? Or can I use the quick systems that will give me a small amount of energy back, but they're quick, but in the long run, they actually start to fatigue me pretty badly. So the body has 3 different energy systems. And what I want to do is take a little bit of time right now to have you pause this video and maybe on that same piece of paper that you wrote before about a note of what ATP is, I want you to take a note about the fact that the body has 3 different energy systems, that one of the energy systems involves a lot of oxygen, it doesn't fatigue you, and it gives you a huge amount of energy back when it works. But the other 2 energy systems, they don't use a lot of oxygen or any oxygen at all. They happen quickly, but they only give you small amounts of energy back. And the bad thing about those 2 energy systems is that they fatigue you. So hit pause, write a note about that, rewind if you need to, and then when you're ready, press. Now that you've unpaused that and hopefully you've got a note about what ATP is, hopefully you've got a note that there are 3 energy systems. As you can see, I've set the board up here ready to explain a little bit about each of those 3 energy systems, which you've already been introduced that one likes oxygen and uses oxygen and the other 2 do not. Some of them are fast, some of them are a bit slower. Some of them give you a big amount of energy and the others give you small amounts of energy. What's really hard for a PE teacher to teach you about the 3 energy systems is the fact that all 3 energy systems are always running. Right now inside my body, all 3 of these systems are giving me energy. Usually, 1 out of the 3 systems will be giving you most of the energy that I'm using, and the other 2 are just working slowly in the background. And then when I start doing a different type of movement, whether it be faster or more explosive or requiring a big amount of force, like lifting something heavy, the body might tick over to use another system more than it uses the other two. And so all three are always working, but one is working more than the other two. None of these systems ever switch off. So the first one I want to talk about is from the race that you just saw. That very famous man running is Usain Bolt. He holds the world record for the 100-meter sprint. And we often use him as the example because his energy system mainly requires very, very quick amounts of ATP being put back together. As you can imagine, I mentioned all those muscles before, and every single one of those muscles needs ATP, 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 and once it uses it, it needs ATP again, ATP again. And so we need to find an energy system that's going to give us quick ATP. And the energy system that he uses, for the most part, because all three are always working, is called the ATP-PC system. ATP, we know, is adenosine triphosphate, and PC stands for this thing called phosphate creatine. And some of you might have heard of creatine before. And we talk about enhancing performance of an athlete. Creatine is something that can enhance the performance of an athlete. Phosphate creatine is another bond-like substance inside the body, like ATP. ATP has adenosine and 3 phosphates all bonded together. Phosphate creatine has a phosphate and a creatine bonded together. And when the body says, I need ATP, if we have any of this phosphate creatine lying around and we can break it apart, it releases energy that allows ATP to be put back together. And this energy system doesn't use any oxygen. So it can happen really quickly, and pretty much one phosphate creatine break allows almost one ATP to be put back together. And so it's almost like I've got a reserve store of ATPs, because if my muscles as I'm running are going ATP, 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 and then all of a sudden I start to run out of ATP, if I can do PC, ATP, PC, ATP, PC, ATP, then I can almost continue to run as fast as I could. Now, it's important to know that the amount of ATP that we have inside our body is roughly, for high intensity running, 3 seconds. Once those muscles have used 3 seconds of high intensity running, we're almost all out of that, and we need to start putting it back together. And if you want to keep running as fast as you can, you're going to find some phosphate creatines and put that back together. Happens very quick. One PC roughly puts one ATP back together, but there is a downside to this, and that this energy system roughly can only last for about 10 seconds before the amount of PC, phosphate creatine, inside your muscles is also gone. So ATP, bang, 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 bang. Once it's used up, we find some PC, bang, 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 bang. 10 seconds later, on that Usain Bolt 100-meter sprint, 10 seconds, world record, we've run out. We need to now use one of these other two systems as our main supplier of energy to put this ATP back together. I want you to hit pause. If you need to rewind and rewatch this, I want you to take about 5 dot point notes about this ATP-PC system. The fact that it's quick, the fact that PC is stored in the muscles, the fact that PC can break apart and put ATP back together using the energy that was released. And also the fact that this is a fantastic system, but only for about 10 seconds before we run out of PC if we are going at very fast, high intensity. Now you're starting to understand that muscles change their shape. When they change their shape, they're contracting, they're moving together. They move bone to bone. That happens in the leg, in the ankle, in the hips. Anytime we find a joint around the body and we want to move, muscle contractions occur. When those muscle contractions occur, the only thing that can move a muscle is that compound ATP. ATP only has a very small amount stored in the muscles. And so if you want to move the muscle over and over and over again, you're going to need to find a way to put ATP back together. What was lost when the ATP breaks apart is energy. What do we need to put it back together is energy. And so we find one of these 3 energy systems. All of them are always working, but one will be producing more energy than others at any time. And so one of the ways that we can do it and it's a very simple way, is to find some PC, phosphate creatine. It's another chemical that's sitting inside that muscle. And the moment that we need quick energy, PC can break apart, which releases energy, put ATP back together, and allow that muscle to keep moving. But the problem is, we've only got about 10 seconds worth of high explosive phosphate creatine energy. What I would like you to do now, as I said, this is a very different lesson, is I want you to, once I've explained this, pause the video. I actually want you to head outside. Hopefully the weather's okay when you're watching this. I want you to head outside and I'm going to ask you to go for a run. Do a little bit of a warm up first just to make sure you don't get any injuries. And the run that I'm going to ask you to do is going to be explosive, high intensity, sprint. But I'm going to ask you to sprint for 25 seconds. I don't want you to go for a big run. I just want 25 seconds. So you might be able to go outside your house and you might have a long bit of pathway that you can run on. That's great. I only want you to go about 12 seconds one way, turn around and go 12 or 13 seconds on the way back. 25 seconds of as high intensity sprint as you possibly can. Please, if you do this properly, the next part of the video you will make huge amount of sense from and get a massive benefit in year 11 and year 12 if you do that exercise properly. Pause the video now, head outside, explosive as fast as you can, 25 seconds running. Good location, but we're back and hopefully you've been out for that run, 25 seconds as hard and fast as you can. And now that you've got an understanding of what's going on, you've seen your bicep make that one movement. Now you're understanding that the calf would have been making that same movement as your bicep did when lifting, but it would have been making that movement 100 times during that same run, 25 seconds explosive that you just did. And that would have been the calf on both legs, also your hamstring on both legs and the quadricep on both legs and the glutes on both legs, as well as the core tensing to try and keep the body up nice and straight. And if you were going as hard and fast as I'd asked you to for 25 seconds, then it would have been shoulders and chest as well to be able to drive your arms forward. So like we saw with Usain Bolt, it's the whole body requiring the muscles to explode and move over and over again. So one thing that you should know now is that because we were going at an explosive rate, first couple of seconds, the ATP stores inside the muscles were probably depleted and gone. For the next 7 seconds or so to get you through to that 10-second mark of high intensity sprint exercise, hopefully you've got an understanding that your muscles would have had some stored phosphate creatine, and that phosphate creatine would have been pop, 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 putting ATP back together to allow you to pop, 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 continue to run and move those muscles. But the question is, what happened after the 10-second mark? How did your body get from the 10-second explosive sprint mark to the 25-second mark? And the other question that goes with that is, did your muscles slow down their contractions? Were you less explosive? Did you slow down from your first 10 seconds and your last 10 seconds or 15 seconds? Were you able to sustain the same speed as the first 10 seconds as you are in the last 15 or 10 seconds? Technically, if you went as hard and fast as you were trying to, the answer is no. Because chemically, we understand that inside our body, your body would have essentially run out of stored ATP and run out of phosphate creatine to put ATP back together quickly. And you would have had to rely on one of the other 3 energy systems to become the most dominant and give you energy back. The next energy system that the body relies on in this high intensity sprint is actually called an anaerobic glycolysis system. It's a bit of a mouthful, it's kind of hard to remember, but it makes sense when I make this explanation to you. So, the word anaerobic means without oxygen. Because if I said to you at the 12-second mark of your run, was your breathing rate and your heart rate at the level that it would have been at for you to be able to run at that pace for an hour? And the answer is no. If you had a heart rate monitor on, you would have noticed that the heart rate is starting to increase, but it never would have leveled off for 25 seconds. While your body is trying to match the amount of oxygen that it needs by bringing more in and by pumping it around the body faster, the body has to use anaerobic, without enough oxygen, glycolysis. Glycolysis meaning break down glucose. Glucose comes from the carbohydrates that you've eaten. So essentially, this system here says, okay, I've run out of phosphate creatine. I'm running out of ATP. I need to put ATP back together, which means I need to put energy back in. So it finds some of those carbohydrates that you ate yesterday, last night, this morning, and it starts to go through the process of breaking them down to take the energy out of the carbs that you'd eaten and use that energy to put ATP back together. But as you can imagine, that is going to be a slower process than what finding that quick phosphate creatine is to break that apart. So when the body has to go and find the glucose that's come from the carbs that you've eaten, that process takes a lot longer for the body to be able to find it and give energy so that ATP can get put back together. So this one here is about using the carbohydrates that we've eaten without oxygen in the muscle. When that happens, this energy system creates something that's really quite bad for your muscles during a run. And that thing you've probably heard of before is lactic acid. Lactic acid essentially fatigues the muscle. So now not only do we not have something that's as quick as phosphate creatine to put ATP back together, but now we've actually got something that takes longer to find the glucose from the carbs, not enough oxygen, find the energy, put ATP back together, but now we're actually producing something that's going to slow our muscles down called lactic acid. What I would like you to do is pause the video and write a set of maybe 5 dot points, same thing, explaining that this energy system uses the carbs that we've eaten as glucose. There is not enough oxygen in the muscles yet, so it breaks down that glucose with this glycolysis process. And when it does that, yes, it gives us energy to put ATP back together, but it also is going to produce lactic acid, which is going to fatigue the muscles while running. Write those notes down and then press play again. We're on to almost the final section of this video, and I'm really hopeful that you found this interesting, helpful, and really insightful when you head into Year 11 and Year 12, physical education in particular. This is a passion for Mr. Sharp and I and a lot of the PE teachers, and we really hope that if you have any questions, let us know. Send us an email, ask for a Zoom, have a chat about this, because it's really exciting to us, and hopefully you guys carrying forward that flag for Year 12 PE in a couple of years' time. The question that still arises though is, I've used up ATP in my stored muscles, couple of seconds, explosive. I've used up my phosphate creatine, Usain Bolt example, 10 seconds, pretty explosive. And now I've gone into anaerobic, not enough oxygen, glycolysis, breakdown of glucose, which has come from the carbs I've eaten. The carbohydrates I've eaten, they're breaking down, they go store in the muscles, I use them to put ATP back together and keep moving my muscles. It's a bit slower. But as I just explained, that if there's not enough oxygen present and that process happens, I'm going to build up lactic acid, and lactic acid fatigues the muscle. So after a short period of time, that muscle can't keep making its contractions because of the lactic acid that's built up in that muscle. So the question is, if I was to say to you guys, get on a bike, go on an elliptical trainer, go on a treadmill, go for a walk, and I want you to go for a 1 hour walk. I want you to go on the bike for 1 hour. I want you to go on your elliptical trainer for 1 hour. I want you to do star jumps for 10 minutes. Each of those activities has gone longer than 10 seconds. It's gone much longer than 4 or 5 minutes. The question is, how does your body keep putting ATP back together for that length of time when we know that phosphate creatine is going to run out pretty quickly? And if we keep building up lactic acid, then we know that the muscle is going to stop at some stage or another. So the question is, what is this third and final energy system? And how are athletes and other individuals able to sustain long duration exercise? I want to share with you something. This is from an app called Strava. Some of you might have used it before, which is fantastic. Strava actually helps map your runs. So with my Apple Watch, and I go for my running, I always just map it, and it goes for however long my run goes for, and it gives me a few bits and pieces of details as well as GPS tracking. So this run that I went on, I went for 23.5 kilometers. It's a fair distance. I was running roughly 5 minutes and 25 seconds per kilometer, but as we'll see, there's slight difference there. There was a fair bit of uphill in my running, 171 meters. And my total moving time before my body said, that's enough, was 2 hours and 7 minutes of non-stop running. The heart rate averaged out at about 170 beats per minute. And just so that you know, my average resting heart rate is around about the 60 to 65 beats per minute. So that's up quite a bit from where it rests. If we move on and have a look here, this graph is what I want you to have a look at. This here is a 4 minutes and 30 seconds pace for my run. So any of the lines that are around about there means I completed that kilometer in that time. And this here is a 6 minute kilometer. And anything that's down here is where I completed it in roughly 6 minutes. So you can see that the decline in my performance meant that each kilometer was slightly getting slower and slower and slower. I was okay during this section here of staying relatively consistent with a couple of faster ones, but once we'd hit this point, you can see that the times took longer and longer to get through each of those kilometers. So on this next one, it actually goes through each and every kilometer and roughly how quickly I was able to run it, what was my heart rate during that kilometer, excuse me, and was I going uphill or downhill during that kilometer? Once I've shared that with you, the question surely has to be asked, how are you able to run for the full 2 hours? And the biggest answer I can give you is this. The pace in which I completed the run decreased. The intensity decreased. What I was able to do was say, okay, I don't want to run as fast as I can, like Usain Bolt. For your 25-second run that you just did before, if I said to you, go and do that for 2 hours, you would not run at that same pace. And so if I back the pace off, I am able to sustain energy for longer. I don't need it to be as explosive, bang, 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 bang. My body probably doesn't want to rely on phosphate creatine as much, or anaerobic glycolysis where it's going to build up the lactic acid. And so if you have an understanding that by changing the intensity of your run, you are able to last for longer because you won't get as fatigued, that is a really good place for you to be in. So what I would like you to do right now, take a break, pause it, walk away from the computer, come back, and when you're ready, unpause the video, and we're going to go through the third and final part of these energy systems for you to take a couple of notes and then finish off the lesson. Unpaused, and we're ready to get into this final section of the video. The question is, how are you able to run for a long period of time? The answer, decrease the intensity. By decreasing the intensity, you decrease the amount of oxygen that your body needs to be able to be in this third and final energy system. The one that I spoke about very early on, which is the one energy system that works with oxygen. So right now, I'm using this energy system because I don't need a lot of oxygen. I only need a small amount of oxygen, which right now I'm standing here I'm getting enough oxygen. So I'm able to stay in this energy system for as long as I want, with it producing the most amount of energy for my body, because I don't have high intensity needs right now. If I go for a walk, it's fine. If I go for a jog, it's fine for a few hours. If I start going to a run, it lasts for a little while. If I go to a sprint, it's not going to last for a very long time, because I need these two. So this energy system is actually super similar to energy system number 2, the anaerobic glycolysis. This energy system is the aerobic glycolysis system. And the processes that happen inside your body are nearly the same. The body has the carbs that it ate yesterday and this morning and last night. The body finds the glucose in those carbs, it breaks it down. And the body finds the energy inside that glucose to provide ATP to be put back together. But the difference here is that this carbs, or the glucose, is actually not preparing us energy for ATP without oxygen. It is giving us energy for ATP with oxygen. That's the big difference right now. And here's the thing. When we were creating energy from the carbs or the glucose without oxygen, the body was creating this thing called lactic acid, which slows our muscles down and hurts us essentially. Now that the body has enough oxygen, we're going for a jog, the heart rate is elevated, the breathing rate is elevated, and it's staying nice and steady, and I can run for 2 hours and 7 minutes, no problem. The body is calling upon this energy system to provide me with ATP again, and when it has enough oxygen, instead of creating lactic acid, it's going to give me a couple of things. It's going to give me heat. Heat's fine. You can actually see on a cold morning somebody who's gone for a run, steam coming off their body. It can evaporate out of me. And sometimes it's even better, because when the muscles are warmed up, they're not going to tear. They're nice and stretchy. So heat can be a good thing. One of the other things it produces, I'm sure you've all heard of before, H2O, water. Now, if I'm heating up and my body wants to cool down, some of that H2O that's being produced from carbs with oxygen actually sweats and cools me down. One of the other things that this energy system creates is CO2, carbon dioxide. I breathe it out all the time. So instead of creating lactic acid, which hurts the muscles, this energy system creates heat, water, and carbon dioxide. And it also gives us a large amount of ATP. It doesn't happen quickly, because there's a lot of processing that happens. But when it does happen, it gives you a lot of ATP. So you can run at a lower intensity for longer. Same thing as you did for the other two. 5 dot points about the fact that this is glycolysis again, the breakdown of glucose. It's come from the carbs we've eaten. Now there is enough oxygen. It's a lower intensity because it's slower, but it only produces heat, water, and carbon dioxide, which are all things that are manageable. I really hope you've enjoyed this lesson that's all been centered around introducing you to the body's 3 energy systems. What I would strongly recommend is that you save this video, okay? Find somewhere that when you do head into Year 11 PE, you can rewatch it. When you head into Year 12 PE, you can rewatch it. Save these notes somewhere. This is going to be vitally helpful for you as you move forward with your physical education studies. The energy systems underpins everything else, and hopefully, you can start to understand now a little bit more detail about recovery that we learnt over the last few weeks, or even how an athlete can make sure they've eaten the right amount of carbohydrates or carb loaded, like we learnt in legal performance enhancements, about how this is actually working inside the body. I'll see you next week.